Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is maximum difference between node and ancestor. So the challenge statement goes like this: given root of a binary tree, find the maximum value v, for which there exist different nodes a and b, where v is equal to uh, value of a minus value of b, and there is absolute difference of this value of a minus value of b. Okay. uh, and it's mentioned that a is an ancestor of b. Also, those of you who do not know what ancestor in a tree is, it's mentioned in the problem. uh, a node a is ancestor of node b if either of this is true. If any child of a is either equal to b, or any child of a is an ancestor of b. Okay. So if we take this particular uh, input as example, simple input, then let me magnify it. I don't know why it's not working. Anyhow, let's take this itself. It should be okay, not a problem. I think this should be visible enough. Let's say this is a, then b's value can be either of 14, 13, any of them. Okay. And let's say this is a, then b's value can be any node from this group. Or let's say this is a, then b's value can be either this or this. Okay, these two are suitable candidates for values of b. Okay, so we are just concerned about if you are picking, let's say, x node as a, let's say this is x node, then all the nodes that are lying below in this direction of this node are suitable candidates for b. Okay. And a will be the ancestor and of b. Okay. A will be ancestor of b. B can be any of these nodes, so that would be fine, not a problem to us. Okay. This is what the problem statement mean by ancestor. Okay. So, and you have to find the maximum value of a dot value minus b dot value. So here in, if you see in this particular tree, what will be the maximum value that we can get of a dot value minus b dot value? It's 7 of these two nodes. Why it's not working now? Yeah, it's fine, I think. Of these two nodes. Okay. 7 absolute difference, because if you do 8 minus 1 absolute difference, it will be 7. This is A here, and B is this. Okay. So that's the answer for this one. Let's have a look at the constraints also. So the number of nodes will be ranging from 2 to 5000, and this node value will be from 0 to 10 raised to power 5. Okay, these are the constraints. So how to solve this kind of problem? Basically, we want to maximize it, so we will be using a greedy approach. Okay. And what would that greedy approach be? For each node, we will find two values. We will find two values, uh, minimum and maximum values of nodes occurring in a subtree with current node as root. Okay, so let's say this is the subtree you are selecting. Okay, then in this particular subtree, and this is your current node, let's say, let me change color here also. This is your current node. So the subtree having this node as the root node is this is subtree having current node as root. What will be the maximum and minimum values excluding this current node we are talking? Excluding current node. Okay, so whatever will be the maximum and minimum values in this part, we will return to this current node. So they will be it will be 4 and 7. Okay, this will be the minimum value and this will be the maximum value. So we will be returning couple of integers from each node to its ancestors. So let me write it down also. We will return uh, a pair of values from each node to its ancestors. So for let's say 4, it will be 4 comma 4, since 4 is the only value here. And for 7, 7 will be giving 7 comma 7. Okay, now 6 will be receiving these two inputs. Whenever 6 receives these two inputs, it will update maximum and minimum value at 6, including 6 here. So it will be nothing but this 4,7. Okay, so 6 will be returning 4,7. Okay, now 3 will be receiving two inputs. One is 4,7 from 6 and another is 1,1 from 1. Okay, 1,1. I hope it's visible. 4,7 is received from 6. 6 was receiving 4,4 and 7,7. And then similarly it will continue. 8 will be receiving 1,7 from 3. 3 will be sending 1,7. And similarly 13,13, and here 13,14, and then here 10,14, and then here it will be receiving 10,14. So then it will be calculating two things. Difference will be calculated. So this node will be A here, and whatever that difference will be maximum, we will be returning that. So it will be 8 minus 10 and 8 minus 14, and then 8 minus 1, and then 8 minus 7. Whatever is being maximum of these four values, root will be returning that. So it will be 7 here, and for this I think it will be 6, for this 2, and for this one it will be 1. So maximum among these is 7, so our answer will be 7. So this is how we will be solving this particular problem. Now let's have a look at the implementation. Okay, let me remove these debugging statements. Yeah, so we will be running a depth first search in the tree. Those of you who are new to DFS, a link will be provided. Okay, and we will initialize a global variable maximum difference with 0, and then we will be updating this maximum difference as we keep on traversing uh, the tree in the DFS. So we will be updating max difference as we do a DFS traversal of the tree. Okay, and yeah, if your current value of your root is null, so instead of minimum value you will be giving maximum value, and instead of maximum value, so you will be giving minimum value. So the pair that you are returning is something like this: min value colon max value. So instead of min value you are giving out maximum, and instead of max value you are giving out minimum, and this should be not in the range of the node values. So the node values will be only till 10 raised to power 5, so we are safe with maximum and maximum minimum value of integer. Okay, so these null values will not be picked by any of the nodes. while updating minimum and maximum for that node. So okay, and this value difference is of no use, I think. Okay, and this is the current roots value. Current roots value, which will be denoting current ancestor, or say value of a. Okay, and then you will be recursing for the left subtree and finding the pair. Recurse for the left subtree and find the pair, which is min value, max value in that subtree. Similarly, you will be doing the similar thing for right subtree. And then you will be simply returning minimum, updated minimum and maximum value for this uh, current root node, returning updated pair value, min value and max value pair, with respect to current root node. Okay, and that's the case that the node that is returning value to your current root node is not a null node. Okay, so this is just a check to ensure that we are not updating values with respect to a null node. Okay, and similarly here also. So for the this value will be updated and we will find maximum difference alongside. Okay, also we will be finding maximum difference here, also we will be updating. Okay, and at last we will be returning updated pair value for the current node to its ancestors. Min value, max value for the current root node to its ancestors. So recursion will help us to return the value to the ancestors. So the ancestors will be receiving those values. And at last we will be having the updated value of maximum difference possible in the whole tree. Okay. And this is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then please feel free to use the comment section. Thank you for watching. Have a great day ahead.